yourself about the three different trig functions, sine, cosine, and tangent. And these are the abbreviations you would use in C for sine, cosine, and tangent. There are actually 6 of them. Sine, cosine, and tangent all have a buddy function that we'll be talking about as we kind of look through the first 2 sections. So SOHCAHTOA was a way to help us remember how to find the sine, cosine, and tangent, because the sine, cosine, and tangent are actually proportions of sides of a triangle. So Chelsea, the sine would be equal to what 2 sides of a triangle?
Opposite over hypotenuse.
Right, so the sine is the opposite there we go, and the hypotenuse. So it's a ratio or proportion of one side to another side. That's how we could find an angle. Or if you know an angle and a side, you can find another side. So you can use this little proportion to find different pieces of a triangle. Chelsea, the ka in SOHCAHTOA represents
Adjacent over hypotenuse.
and then the tangent is
Opposite over adjacent.
opposite over adjacent. So in the triangle, opposite and adjacent are based off of the fact of the angle that you're looking at. So for the first 3 on the left, it says we're using angle B. So opposite is across, adjacent means near, next to, adjoining. Hypotenuse is always across from the 90-degree angle. So if you draw yourself a little 90-degree angle, the hypotenuse is always across from the 90-degree angle. That never changes. The hypotenuse is always in the same location as the biggest side. So we're going to just see if we can write a couple proportions here just to kind of refresh. So sine is opposite over hypotenuse. Looking at angle B, that's the bottom left here. So opposite across would be side B. Hypotenuse is side C. And we're just leaving it as a ratio representing the sides in the triangle. So if I wanted to find angle B, and I knew side B and side C, we can then calculate that value. So the cosine of B, Brandon, would be adjacent over hypotenuse. Which side is adjacent to angle B over here? A, and the hypotenuse is still C. And then Brandon, the tangent opposite over adjacent would be?
B over A.
Right, B over A. So opposite and adjacent, B over A. So the other 3 just change perspective a little bit because now you're looking at the top where angle A is located. So across would be opposite, adjacent is still the one next to it. In this case now it's side B. So we're looking at opposite, which is A, hypotenuse is C. The hypotenuse is always C, no matter what angle you're at. Hypotenuse is always the biggest angle. Alice, the cosine of angle A would be?
B over C.
And then the tangent of angle A?
A over B.
So if you look at those 6 values, what do you notice about those 6 values? Brandon?
Sine B and cosine A are exactly the same.
Yeah. So sine B, cosine A, they're exactly the same. And cosine B, sine A are exactly the same.
And tangent B and tangent A are inverses of each
Yeah, they're just reciprocals of each other. And that is a property that we will talk about based off of specific angles and triangles. But that holds true because of a specific property. So not like it's by chance that actually happens. All right, so that was SOHCAHTOA. I don't even know what chapter you do that in geometry.
I feel like it's halfway through the year.
Yeah, that sounds about right. All right, so the other little review from geometry were the 2 special types of triangles. And these triangles are called special triangles because of the angles, the 30, 60, 90, the 45, 45, 90, and the way that we can easily find the measures of the sides of that triangle if you have a triangle that has these specific angles. So any triangle that's 30, 60, 90, there's a little shortcut that we can find the lengths of the sides. When you're labeling a triangle, we try and label the triangle, like the shortest side goes with the smallest angle. So if my short side is at the bottom there, angle 30 should be then across from it. Angle 60 is the second, so that would go against or across from the second longest side, and then the 90-degree angle would be that hypotenuse. Your sides should correspond as best as we can with the measure of the angle. Of course, if they're the same, then both of them are 45. All right, so I know geometry, this was like 2 years ago. Does anybody remember? It was a pattern, a formula, a way to find the lengths of the sides just based off of the fact that you have a 30, 60, 90 triangle. So we're not using sine, cosine, tangent, just looking at the sides of the triangle. Virginia, what do you think? Okay, so what'd you say? The hypotenuse, yeah. So the hypotenuse is twice the base, and I'm just going to call the base A. Okay, that doesn't go to. So base A, the base across from the 30 is the base. The hypotenuse is twice the base. So that's how we can calculate the hypotenuse. If you know the base is 5, the hypotenuse is 10. It's double that. What about the vertical leg, though? Chelsea?
Isn't it the square root of n?
You're so close. There is a square root in it. So it's A times the square root of 3. So you're taking that base, you're multiplying it by the square root of 3 to get the other leg of the triangle. Oh, I mean, sure you could, but what happens if you're given the side across from the 60 and you don't remember that it's 8 times the square root of 3? Yeah, pretty much, yes. You don't know what to do. Yes, that's about right. So the other one is 45, 45, 90. If the angles are the same, what do you know about the sides that are across from them, Brandon? They're the same length. What type of triangle is this called? Isosceles. So they're the same length. I'm just going to use a B. You can use whatever you want. They're both legs. The legs are the same if the angles are the same. How do we find the hypotenuse when you have a 45, 45, 90 triangle? It's B times the square root of 2. So believe it or not, after you do the worksheet, you'll have them memorized. Because you'll do it a couple of times, it'll go back in that memory bank. So we are going to see if we can, underneath, just kind of find the lengths of the sides. If you're given one side, you can find the other two by using one of these patterns. If it's one of these special triangles. If it's not, then you have to use the Pythagorean theorem or sine, cosine, tangent. So at the bottom here, we have 45, 45, 90. That's the first one. And we're asked to find the hypotenuse and the base. Those are the two pieces we're asked to find. So knowing it's 45, 45, 90, we know that both of these should be the same. And the hypotenuse is supposed to be B times the square root of 2. So that's just because it's a 45, 45, 90 triangle. It has a special pattern. So that means then, Eris, that the hypotenuse is, give me an exact answer, no calculators.
Alright,
Yep.
so 4 square root
4 square roots
of 2.
of 2. So unless it says to round to a specific number, we will always have everything exact. So radicals will be in 95% of our answers. Pi will be the other thing that you'll see in 95% of your answers probably. So a square root or a pi will be part of all the problems we work with. The value pi, the little symbol pi. And then the b value, well, if I have one side is 4, since it's 45, 45, 90, the other side is also 4. So the hypotenuse is 4 times the square root of 2 because it's that base value times the square root of 2. And the other side is also 4. In the middle one, we have 30, 60, 90. So the key thing is to kind of look to see where your angle is, where that 30-degree angle is, and what's across from it. So Cade, the hypotenuse in this case would be?
Would be 4.
Would be 4 because you're doubling A, so here's A. And then the vertical length here, Kate, is
2 times the square root of
right, 2 times the square root of 3. So the pattern says a times the square root of 3 for the vertical length across from the 60. Hypotenuse is twice or double a, and the side we have would be 30, which is the little side of 2. Okay, so then the third one, same type of problem, except, Brandon, we know the side across from the 60 is 6. But because it's 30, 60, 90, that's equal to a times the square root of 3. This side is supposed to be a, this side over here is 2a. What do you have to do to find the other sides? So we know one side is 6. How do we get the other two sides? Nick?
You have to divide by the square root of 3.
You do have to divide by the square root of 3. This is like a little equation. If we want to find a, we need to get a by itself, so we need to divide by the square root of 3. So we now have a equals 6 divided by the square root of 3. Nick, do you think we can leave it like that?
No.
Yeah, what do you have to do?
You have to get the square root out of the denominator.
So what? Multiply by.
Square root of 3.
Yeah, the square root of 3. So we gotta get that square root out of the denominator, so we'll multiply both top and bottom by the square root of 3. So then we have 6 square roots of 3 divided by 3. And then Nick, does that reduce it all?
You can divide the 6 by the 30.
Yep, so that becomes
2 square roots of 3.
perfect, 2 square roots of 3. So my base side, that little side at the bottom, is now 2 square roots of 3. All of that represents a. So then if we want to find f, we have to double this value because it says the hypotenuse is 2 times a. Well, this now represents a, so if we double it, we have 4 times the square root of 3. Questions? Nice job, Nick. All right, so if you flip it on the next page, I think your picture looks a little better than mine. Mine look like they're slightly off. So we have these two triangles. It says label the sides of the triangles. And then we're going to use the triangles to answer the questions at the bottom. And yours are all lined up vertically. So we're going to see if we can try and use these triangles to answer the questions underneath. So again, here's the side of 30. So the 60 is a square root of 3. The hypotenuse is 2a. So just plugging in the number that you have for A or that you have for B. So if we double A, we get 4 for the hypotenuse, and then 2 times the square root of 3. So A is 2, and we're just using those numbers. So it says find the following values. All answers must be in simplest radical form. So no decimals. We'll have nice fractions in an answer if it happens to have a fraction, and since we're trying to find sine, cosine, tangent, probably have a fraction as an answer. You might want to remind yourself that if we're finding sine, cosine, and tangent, just so you have a visual to look at, we're finding SOHCAHTOA. So Libby, the first one says the sine of 30 degrees. So we're going to use that triangle on the left. If it's 30 degrees, what would the opposite side be?
2.
2, and the hypotenuse is 4, and that reduces to
1/2.
1/2, and that's it. So the sine of 30 degrees is 1/2. Libby, how about the cosine? What will we use for that one?
2 square root of
And the hypotenuse is still
4.
4, and that reduces to
1 and 1, or I guess you could do square root of 3 over 2.
perfect. Yeah, keep it as one fraction. The square root of 3 over 2. I know that seems weird, but just keep it in one fraction instead of saying a half square root of 3. Just square root of 3 over 2. And then the last one, the tangent. So that's opposite over adjacent. So the opposite is 2, the adjacent is 2 square roots of 3. How would that simplify? So what could we do, Brendan? One thing we could do to simplify that.
The 2's can cancel out, so it would just be 1 over the square root of 3.
Okay, so 2's cancel. You get 1 over the square root of 3. And
you
then,
have to multiply by the square root of 3, so it would be the square root of 3 over 3.
nice job. So multiply by the square root of 3 and you end up with the square root of 3 over 3. So that would be the tangent of 30 degrees. Any questions on those? So just working through the other ones then, 45 degrees means make sure you're using the opposite triangle, the one on the right side. So we have the sine, opposite, hypotenuse, 2 square root 2. And you'll find that like working with radicals, you'll get really good with working with them, simplifying them, because they're going to be in a lot of the problems. So Michael, how could we reduce this one?
You do the same thing, 1 over square root of 2, and then multiply top and bottom of the square root of 2.
And that becomes?
Square root of 2 over 2.
Michael, what do you find for the cosine of 45?
You would do the 2 again, and then over the 2 squares of 2, so it would just be the same thing.
It's exactly the same thing. And that's because the opposite and the adjacent side are both the same. So since your opposite and adjacent sides are the same, the sine and cosine are going to do the same as well. And then for the tangent, Michael, what'd you get?
The tangent, you would do 2 over 2, so that would just be 1.
Right, the tangent's just 1. Because if the opposite and the adjacent side are the same, that'll reduce to be 1. So the last one on here, going back to the first triangle, looking at the top angle 60. Brandon, how about the sine of 60?
2 times the square root of 3 over 4.
Which is?
The square root of 3 over 2.
Cosine of 60, Brandon?
2 over 4, which equals 1/2.
And then the tangent of 60.
2 times the square root of 3 over 2, which equals the square root of 1/2.
Nice. So do you think these values would change if we changed the numbers in the triangle? No. Every sine of 30 degrees will always be a half. It doesn't matter that I make this a 4, this becomes an 8, because 4/8 is still 1/2. So you can have any number, any length of a side in a triangle, the sine of 30 degrees is always 1/2. You can put that in your calculator. So you can type the sine button in the calculator, hit 30, and enter, and if your calculator's in degrees, it'll tell you that it is 1/2. So the sine of 30 degrees is always 1/2. Those are some of the numbers that are on those cards, or the facts that you're going to start memorizing. If you look at the yellow packet that I gave to you, what did I do with my extras? Oh, here they are. The front of the yellow packet has this beautiful diagram on it. So pretty that I had to screenshot it because I can't really draw that perfectly on my phone. This is called the unit circle, which is kind of like trig is based off of this diagram. So these triangles create this diagram. Just those 2 triangles create this entire diagram. We are going to create this diagram on our own on Friday. And I'll show you how the numbers are created, how those triangles create every single one of these ordered pairs. This is a great thing to have. Don't mess it up. Keep it nice and pretty. Don't write on it, because as you're working through homework problems, it's really nice to have this on the side of your, wherever your workspace is, to have it as a reference point. This will be memorized, all of them. And you'll be able to fill it out probably in 5 to 10 minutes. Like, you'll just have them in the back of your mind, memorized very quickly, I promise. There are like little cheats and tricks, little cheat sheets that we'll kind of talk about, tricks to use so that you're really not memorizing 32 ordered pairs, but instead you're memorizing a handful, more like 4 or 5. But I taught the class for 13 or 14 years. I've gotten really good at explaining this, how it's all created, and making it relatable so you can kind of understand and remember it easily. So this little guy here, like, don't ever lose this packet, especially this page, because until we're done with trig, you may even want to keep this for next year. Because like she starts off right away that you need to have this memorized. forever until you're done with that. Brandon?
Will all the ordered pairs that are fractions, they're all over 2.
They are all over 2, yes.
Why?
Well, we'll talk about that on Friday. I promise, I'll show you exactly where they all come from. I promise. I wouldn't just say, here it is, memorize it, with no explanation. So we are going to, if you flip into the packet, like, I don't know why they made this as like a separate cover page. So then you open the packet up and it's blank. And the actual notes are on the back of the front page. But when I send my notes over, I already have it like formatted so that I don't have a blank page, but they made a cover page. So every starting of the notes, well, this drives me crazy, so maybe it'll drive some of you crazy, but they all start on the back of the page. Just instead of starting on the front. Doesn't drive anyone crazy, just me. You don't care where you're writing your notes. I hate turning and being like, oh, it's not starting on the front of the page, it starts on the back. It's me being OCD, I guess. All right, so we're going to talk a little bit about trig today. So that was pre-trig. That was geometry. Now we're going to start talking about some trig definitions, specifically looking at angles. There's no homework on this for today. The homework will be on the triangles and in that little trig sheet. So that little trig packet, that's where your homework would be. But these are some terms that we're going to just kind of start talking about so that tomorrow you already have those terms down, and then we can start really thinking about what an angle looks like and how to create an angle in a radian versus degree. So the first term up here is trigonometry, which is literally the study of triangles. And the relationship of the sides and angles of those triangles. Trig is used in navigation, aviation, astronomy, and engineering. So if you're going into any type of engineering, you'll be using trig. So any of the engineering fields expand, they kind of use trig and then expand on it. So that might be a lot of your lives. I use trig because I teach it, but you'll be using it as kind of like the basis of a lot of the applications that you'll do. So an angle, anybody remember like a geometry definition of an angle? I don't know if I have a geometry book in here. Oh, I should. Mr. Clemens has a geometry book. Brandon.
I'm going to go on a limb and say it's the space in between 2 lines that start from a common point.
Space in between 2 lines that start from a common point. Sounds all right. See what his geometry book here has. Oh, they have specific angles. Not just a dummy definition of an angle. Bless you, bless you. Oh, here it is. Consists of 2 different rays with the same endpoint. The rays are the sides of the angle, and the endpoint is the vertex of an angle. All right, sounds okay. Is that what you said?
Pretty much what I
Okay.
said, except I didn't use fancy words.
Except what?
I didn't use rays and stuff. I didn't say that.
Well, it's close, right? So an angle is found by rotating a ray, so we still have that word ray, about its endpoint. So an angle in geometry says that you have 2 different rays that are pretty much already combined together. And an angle in trig, it starts with a side, and then that ray is rotated in some way to get to the end of it to create the angle. Our angles will have movement. In geometry, an angle did not move. You had two lines that stuck together at the vertex to meet and to make an angle. These angles that we draw will have a directional arrow to show the movement of the arrow, or the movement of the angle. The bottom side here is called our initial side, because that's where it starts. Wherever it ends is called the terminal side. And then, of course, this is still the vertex. A vertex is a vertex is a vertex. That's the point where they're meeting, but that point is where it's starting. The ray starts and then kind of moves. So the little directional arrow we will always have in every single angle. If you don't have it, it's wrong. Because an angle can move in different directions, which is why we need that direction there. Standard position will be how we draw our angles. So we'll make a little diagram over here, but standard position is when the initial side is on the x-axis, about positive x-axis, and the vertex is on the origin. Okay, so now I'm telling you that trig is related to an x and y axis and an origin. So we've graphed everything that we could possibly graph, all the functions we could possibly graph on the x, y axis, lines, parabolas, polynomials, radicals, rationals. So we've graphed a whole bunch of stuff on that x and y axis, and now we're going to graph trig on an x and y axis. So that x, y axis doesn't really go away just because we're talking about trig. So our angle has an initial side on the positive x-axis. So that's this right here. So here's our initial side. And then its terminal side ends somewhere else in one of those four quadrants. And it's still the same four quadrants that we've always had. So here's the terminal side. Angles can now be positive and negative. So if it's a positive angle, it moves counterclockwise. So I have a positive angle drawn. The movement of the angle is going counterclockwise. That makes it a positive angle. However, angles can also be negative, which you can't have a negative angle in geometry because they say a negative space doesn't exist. In trig, the negative part shows us that it's going in the opposite direction. So negative angles move counterclockwise. Or clockwise, thanks Brandon. I appreciate you fixing me. So one diagram actually has two angles. It has a positive angle and a negative angle. So the rotation of the angle is important because when you're graphing an angle, it really does matter which way you graph. So which way the diagram goes. So there's one more vocab term, and then we're going to just look at a short little example. The vocab term is called co-terminal angles. Co means two that are usually kind of starting and ending in the same place, joining with each other, and that's what a co-terminal angle is. So two or more angles with the same initial and terminal sides. So if you rotate around in a circle, how many degrees are you rotating around in a circle? 360. So they're found by either adding or subtracting 360 degrees to whatever angle you're given. Triangles are going to be paired with circles. So we're going to kind of pair them together. An angle is paired with a circle and rotating. So rotation is 360 degrees. So one little example right underneath. You know, that was like a lot to kind of take in dealing with angles, but if you just look, for some reason, this is my error when I was typing up these notes. I have 135 degrees, mine's negative, yours is positive. It should be positive. So here's our x, y axis. We're gonna sketch 135 degrees in standard position. So that means we started at the origin, positive x-axis. This is 0 degrees because we didn't move anywhere. What's at the top? What degrees would be at the top of the y-axis? Brandon? 90 because we're 1/4 of the way around. There's 4 quadrants, 4 quarters. 180 would be halfway around. 270 would be 3/4 of the way around. And then of course if we spin all the way around, we said that's 360 degrees. So where is 135 degrees located? Chelsea? Yeah, in the middle between 90 and 180. Draw the direction that it moves. It's positive, so it starts in the first quadrant, moves to the second quadrant. So here's 135 degrees. That's the angle. So the last two things up here, we want to then, after we've sketched it, so it's sketched in standard position, we want to find a positive and a negative coterminal angle. So that means we want to know the angle that goes underneath and meets in the other direction. That would be one coterminal angle. How can we find that? Libby?
Subtract 180.
Not 180.
Or 360.
Oh yeah,
No,
you're good. So we're going to subtract 360. So 135 minus 360 is? Chelsea? You're so close. Add another 100. Yeah, negative 225. You're good. So that's our negative angle, negative 225. But we're also asked to find a positive angle. We can't use 135 because that's the given angle. What do you think, Virginia? Yeah, so go the whole way around and then continue to go to 135. So angles can spin around a whole bunch of times. Doesn't just have to be up to 360. So if you have your 35 degrees, and add 360 to it, that just means that we've spun around once, one full rotation, and then we've gone an extra space to get back to that 135 degrees. And that's 495. So angles can rotate in a circle an infinite amount of times. We can continue to find more coterminal angles if we wanted to find more.
Would the pair of 135 be negative square root of 2 over 2, comma, square root of 2 over 2?
Question. So again, your homework today is just to do the trig worksheet, the pre-trig worksheet with the triangles. Tomorrow, we'll go into radians and what a radian is, how it compares with the degree, and trying to think about angles in that measure.